We're going to take a look at cardiovascular system, so mainly arteries and veins and some of the ways to differentiate those. Outside of that, we'll look a little bit at the heart wall. We have already done cardiac muscle, so it's not as much that as it is just kind of some of the main layers of the heart on that one. So this one will be 3 episodes on this one, and then we'll move on to the digestive system. And again, plan is to start trying to get all this finished up by about the end of the month here. So cardiovascular system, one of the things we're going to be looking at is the 3 main layers that make up the wall of any blood vessel, with the exception of capillaries. We'll look a little bit at the different types of capillaries, some of the main subtypes of arteries and veins. So to start with, we're going to kind of just look overall at the cardiovascular system. So the main thing here is it's a transport mechanism. We've talked about how the blood, pretty much anything that needs to get in or out of a cell ends up in the bloodstream at some level. And the system of vessels and the heart are there to help move this blood around, so these nutrients, waste products, and whatever else can get picked up, moved around, dropped off, removed, whatever we need it to be doing for the particular substance we're talking about. Again, it's a lot like a plumbing system in a house. You have a pump. In the case here, it's the heart. You have a fluid, which in the case of the cardiovascular system is blood, moving through a set of pipes, which are your blood vessels. Normally, when we look at this, blood flows starting at the heart. It's going to go through these larger elastic arteries to ones that are a little bit more smooth muscle in the wall called muscular arteries, to smaller arterioles, to the capillaries, to the smaller veins, which are venules, back to larger veins, back to the heart. That's really what we look at when we look at most of the cardiovascular flow in the system. So if you look at arteries and veins here, you can see this is showing you the large arteries, medium sized down to the smaller ones, and the capillaries. One of the things you notice is you look at all these, the large veins, medium sized veins, and venules, and same thing with the arteries down to the arterioles. You can see that they have 3 basic layers to them. These are called tunics, much like we talked about with the eye. So we have the innermost layer, the Tunica Intima, the middle layer, the Tunica Media, and the outermost layer called the Tunica Externa. And that's what we're looking at here. So this is showing you a vein. You can see the Tunica Intima is that inner lining. It is simple squamous epithelium, also known as, at least in the cardiovascular system, because we can't just call it simple squamous epithelium, we call it endothelium, which is the lining of those blood vessels. The Tunica Media is going to have some connective tissue / elastic tissue. In a lot of cases, it's also going to have some smooth muscle in it. It really depends on which type of artery or which type of vein we're looking at in terms of what's going to be there. The Tunica Externa is going to be a connective tissue outer layer. In some cases, it's going to be thicker. In veins, it tends to be a little bit thicker. The Tunica Media tends to be a little bit thicker in arteries. Another thing we'll see with veins that you can see on this image right here is they do have these one-way check valves in them, which we will not see those in arteries. So you can see the artery here. Tunica Externa is a little bit thinner. You can see the Tunica Media, much larger, a lot more muscle a lot of times in this one, as well as elastic tissue. Part of the reason for this is the blood vessels that are closer to the heart have to withstand much higher pressure. Because of this, they tend to have a little bit more elasticity to them and a little bit more ability to regulate where the flow is going. Where the veins, it's really about taking the blood back from there, so we see some differences there. So as I was saying, the Tunica Intima is the lining that is right around the lumen. This is composed of endothelium and connective tissue underneath. So what that is really saying, it's a simple squamous epithelium with its underlying basement membrane and connective tissue underneath it. Quite a thin layer on these ones. When we start talking about capillaries, this is the only layer that's there. It allows for diffusion and that to happen really quickly because it is a thin cell. The Tunica Media, or middle layer, easy name on it. It is a lot of smooth muscle on this one. Arteries tend to have more than veins. Again, the arteries are more about divvying up blood based on need, where veins are kind of returning it back. Large arteries, especially those closer to the heart, a lot of times we nickname them elastic arteries. They tend to have a lot more elastic tissue in that Tunica Media and the outside. And again, this is about being able to withstand that pulse pressure from when the heart's contracting to when it's not. Where the Tunica Externa or Adventitia is the outermost layer, a lot of connective tissue in here, collagen and elastic fibers. In veins, this tends to be the thickest layer. In arteries, a little bit thinner. The middle layer tends to be thicker in arteries. Like I said, there's some veins might have some longitudinal muscle running in this layer. Again, one of the things we'll see with veins is they are reservoirs for blood. So when you don't need it, over half your blood supply is in your veins. The smooth muscle in the veins can constrict and it can mobilize those reservoirs under stress and under need. So we see that sometimes. So you can see here the different types of vessels. They, again, have the three basic wall structures the same, but depending on the type of vessel, the layers are going to look a little bit different. So elastic arteries tend to have a very thick tunica media with a higher amount of elastic tissue in it. Things like the aorta, which I'll show you at the end of this, is an example of elastic artery. Lots of elastic tissue because when that heart beats, it's pushing a big bolus of blood out, which can't compress, and the blood vessel has to be able to withstand this big bulge going out and then work its way back in. To do that, it needs that elastic tissue. Where we get to muscular arteries, we're going to see these get a lot more into regulating where blood flow is going at a particular time. So based on need, so if you're running, you're going to want blood supply going to your legs, but maybe not to your digestive system. So we can have muscular arteries to the digestive system, kind of closing up or constricting, reducing flow to those areas, and dilating to those other areas that need it. The main thing it kind of comes down to is all your blood vessels can't be all the way open all the time because there's just not enough blood supply to maintain consciousness at that level. Your blood pressure would drop too low. Because of that, we have to kind of decide where blood is going, when, and divvy it up based on need. You can see arterioles, all the layers are a little bit smaller. Again, compared to a vein of the same size, its middle layer is going to be much thicker on that one. Where you see large veins, thick tunica externa, not a lot in the way of muscle there, a little bit. You can see the main valves in there, and then that tunica intima. Same thing on the medium-sized ones. You can see, again, on almost all these ones, that tunica externa is your thickest layer. One of the things that we'll see as we start to look at these under the scope is arteries, because of that amount of elasticity in the thicker middle layer, they tend to hold their circular shape, where veins we'll see kind of tend to flatten out. And you'll see this a little bit later on. Another thing that's interesting is some of these blood vessel walls are so thick that blood vessels need blood vessels, which is kind of a weird thing to say, but large arteries and veins actually have small vessels called the vasa vasorum that are out in that outer layer. And this nourishes those outer layers because the vessel is so thick in these cases that you cannot get nutrients diffusing from the lumen out. So these vessels need their own vessels. Like it says here, veins have more than arteries. Again, lower oxygen content means we have to deliver blood a little bit better because these veins, again, they've already dropped off a lot of this oxygen, don't have as much available. And you can kind of see it here. You can see the tunica intima, the tunica media, and then you can see those small blood vessels down at the bottom here. This is that vasa vasorum, and like it says there, a muscular artery. And I have a picture that I can show you some of this on. The last blood vessel that we'll talk about on this kind of intro one here is the capillary. And then we'll kind of walk through some other stuff on the next show here. Capillaries, these are the smallest vessels. They contain only that tunica intima in a lot of cases. And we're going to see there's actually different types that are either more continuous or leakier capillaries, depending on what we need these capillaries to do. But the main thing it comes down to is you have a layer of endothelial cells, these simple squamous cells with a little bit of connective tissue underneath, sometimes continuous, sometimes not. But this thin layer allows us to be able to really exchange nutrients very easily with these surrounding tissues because it is such a thin layer for stuff to travel through. And you can see in some cases, the smallest diameter of these ones, red blood cells about 7 microns. So in some of these capillaries, you're basically, I would say the big blood vessels are like a 50-lane highway. When you get down to some of these capillaries, it's like a 2-track road. Parasites are these, and it's pericytes, not parasites, like the stuff that's bad. These are small cells that help to repair blood vessels when there's damage to it, forming new wall and connective tissue. Like I said, the other thing with capillaries is there is 3 basic types depending on how continuous this epithelium is and the base. So you have what are called continuous capillaries. Fenestrated capillaries are the most common type. These are the ones that are pretty continuous in terms of the epithelium and the connective tissue surrounding them. They don't have any slits or openings. The wall is pretty much solid. And again, some of these will have vesicles and other stuff that can help move stuff across here. So you can see in terms of the continuous capillary, endothelium butt right up to one another, continuous basement membrane over the whole thing. Fenestrated capillaries, on the other hand, these are in areas where we need a little bit more fluid or other stuff to be able to travel through here. So these are pretty much openings that have a thin membrane covering them. Again, the basal lamina is still there, but substances are able to, a little bit bigger substances are able to get out. So when we look at it here, you can see little openings within those cells. Again, still continuous basement membrane, but they have these little slits that let this happen. And we can see these little fenestrations in these little gaps right here. One of the places we see this is actually in the kidneys when we're doing a lot of our filtration formation in terms of urine formation. Sinusoidal capillaries, easily the leakiest ones here. These have large, they're a little bit bigger, blood moves really slowly in them, and they are incredibly leaky. So there's spaces between the endothelial cells. There's endothelial cells that don't have any membranes covering them. The basement membrane underneath is not continuous. So you can see here, incredibly, kind of like a really bad leaker hose. Again, these let large cells get in and out of the bloodstream. So things like the bone marrow, for example, you see sinusoidal capillaries because these cells need to be able to get in and out of the bloodstream there. And the other place we see this are in the liver is one of the things that we'll talk about a little bit later on. But this is kind of showing you another one in the spleen. But again, can let a lot of these macrophages get in or out of the bloodstream really easily with having these large gaps in it. Generally, we don't have a single capillary supplying a tissue either because, again, all these cells need to be within maybe 20, 30 micrometers of a blood vessel. Because of this, we generally have a lot of these capillaries branching out and making a whole network in the tissue called a capillary bed. It really, cross-sectional area, it really makes this a lot larger, really means that the blood slows down in these tissues, which, again, lets this exchange happen easier. The other thing is, by branching out and getting a ton of them, we get a very big surface area, which again, more surface area means more exchange. We can pick up and drop off a lot more stuff by having this large bed. So you can kind of see an example of it right here. The other thing that we see on a lot of these is that there is the ability of smooth muscle to surround some of these little entrances into the capillary bed, and those are precapillary sphincters, and really if those constrict, it can close off those capillary beds, or if they're open, it will perfuse the capillary bed. So it's one of the ways we can actually control where the blood's going at any particular time. Again, open it up when we need the blood to get to those tissues, close it down when it doesn't need quite as much blood there. And a lot of times we also have bypasses that can take the blood past these areas. So again, what determines whether stuff moves across here? Obviously, the shape of the type of the capillaries. Does it have fenestrations? Does it have, is it sinusoidal? Is there vesicles present there that can move stuff across? The other thing is size of molecules. Bigger molecules more likely to stay in the blood. Smaller molecules more freely able to travel. Polarity, a few other things like that will also all make a difference in which way things travel. And then one of the biggest things is just concentration gradients. Is it higher concentration or lower concentration, and where is it in higher or lower concentration? So what we'll look at the next time here is look at some of these blood vessels and what's going on with those.